So yeah, perfectly valid, just like those two square brackets. Ugh. Open recent. This one no. So you can do int 2 square brackets, right, equals new int, and then another 2 square brackets. And so then in here, you put your dimensions. Now, one unique thing about this is that you can't have 2 empty ones. I know for a single one-dimensional array, I think you could just do this. Is that wrong? Why is that bad? Array initializer expected? Sure. Okay, so you definitely need, but with a 2D array, you're allowed to have one empty one. There's an empty one in there somewhere. Yeah. I'm not crazy. Only sometimes. There we go. Okay, so yeah, with a 1D array, you couldn't do this. You needed something to give it a size, be it like int var1 equals 9 or something, and then you could put in var1 in here. Like that's legal, but it needed something there, or like manually type out like 0, 1, like that's completely separate. But with a 2D array, you don't have to fill up the second dimension, but this right here is the first dimension. So you can think about this as, so like let's say this is 0, 0. So then the 2-dimensional array looks something like this. With that, it would be with an unknown size. Here, let me put 4 by 7. So that one, 1, 2, 3, 4, 5, 6, 7, no, 7. Yes. It's like you've allocated this space for it. And since we said how long this array is going to be here, each of those individual ones, 7, that means that all of these have 0 in them. Can we zoom in? There we go. There's probably a way to just like auto do this, and I definitely picked an array that was too big that I just like numbers between 0 and 10. I don't think anything about it. Okay, so that would be filled like that. And then if we say ARR 0, 5 equals 20. So we can go to here. So 0 goes in this direction, so it's 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6. So 0 and then 5. So right here is equal to 20. So you can kind of think about it like that. Just a grid like an Excel spreadsheet like this. That's how I prefer to think about it, but however you want to, it's up to you. One thing to note about this specific method that I'm showing you here, and this is going to be important for the lab. Oh, who just joined? Evan, love to have you. Okay, so one thing that's important to note as you think about this is that this can be thought of in many different ways. Here, I'm going to shrink it to be a 2 by 4. Yes. Just so I don't have to write out so much. I definitely did this to myself, but you know, why take responsibility? Okay, there we go. So I'm just making it a 4x2 array. So you can think about this in a bunch of different ways. Just gonna do one big block like that. That's too big. You could think about it as like maybe 0, 0 down here. And so it goes 0, 1, 0, 1, 2, 3. You could think about it as 0, 0 over here with 0, 1, 0, 1, 2, 3. And then lastly, if you see the pattern, we can think about 0, 0 over here. 0, 1, 2, 3, 0, 1. And then within all that, even with the zeros in the different corners, you can technically think about it like this. 0, 0, 0, 1, 0, 1, 2, 3. I'm not going to write out all the dimensions for the things, but just I'll write out where the 0, 0 is. So right here, I'm going to ship this over one. 0, 0, and then a grid there. And here, 0, 0, big old grid there. We'll ship this over. And then lastly, where is it? Here, I guess, sure. 0, 0. So what I'm trying to point out like this is that even though I write it like this, and I personally, like, I think the best way to think about it is like that. Oh, I guess technically this is now 2. I personally think about it like this. You have to make sure that you can imagine it like any one of these, because you should be able to iterate through a 2-dimensional array in any one of these orders from left to right, top down. You should be able to iterate through it in any of these orders. So 0, so this one, so just going link through it. And so the way you do that is through with like a nested for loop. And I equals 0, I is less than array.length plus I for int I j equals 0, j is less than array I dot length plus j. Cool. So then with this, system.out.print line array I j. Why is this mad? Yeah, I'm not doing an enhanced for loop. Okay, so with this right here, let's pull up these two sides. Okay. The ones that I have on the right are going to be more natural than the ones on the left, but it's still doable with our array. So let me go here, to the top. So right now, the current setup we have is going to do this. So 0, 0 so whatever's in the top left, that's what you start your I and j values to. So 0, 0 is in the top left, I, j, and so we're starting at I0 and then going through each j's, then I1 going through each j's, 2, 3. So if what I'm saying doesn't make sense to anyone, please type it in the chat. I can go over a little more slowly, but if everyone's getting it fine, then that's perfect. But do not be don't be hesitant to type that this isn't making sense, because I feel like I'm going through it fast, but no one's telling me anything. Okay, so that's this one. And then right here, so the top left isn't 0, 0 anymore. The top left is now, so this is the first dimension, right? It's 4, 2. So This is the 4. So it's the top thing here is 3, 0. Let me shift all this down one. The top left up here is 3, 0. So that's more important than 0, 0, but I had it there as like a reference. So there we go. Top left now is 3, 0. So how do we get 3, 0 here? Well, instead of starting at 0, we start at array dot length -1. And we go until not less than 0, but greater than 0. And we subtract 1. So now we're starting at 3, going from 3 all the j's to all the j's, 1, 0. So that's starting at 3. And if you can kind of, from this right here, this code, if you can kind of see the pattern, from here it's not 0, 0, it's 0, 3. So I is now starting at 0, so we can just control Z to get back to that. Perfect. But J now is starting at -1, greater than 0, and minus J. So yep, I starting at 0, go through all the J's, but in reverse order. So it's not 0, 3. Sorry, that was a lie. It's 0, 1. Whoops. So 0 and then 1, and then goes till 0, 0, and just goes through this like here. And then last but not least, both of them at their maximum values. There we go. And it is 3, 1. So with this, start it at I is greater than 0, I minus minus. So you need to be able to do all 4 of those, because sometimes you are specifically asked for one of them. In reality, most of the time, it's okay to do just whatever one is more comfortable for you. I personally stick with this one, but sometimes you're asked for a specific one. So make sure that you understand all the different ways you can iterate through an array like that. Now, this way is a little more complicated. So let's go back to our basic for loop with just the zeros. There we go. Okay, so this is like the basic one that we had here. So now we're starting at 0, 0, but we kind of want to like switch I and J. So here I is array.length and then J is array I.length. So we want to switch I and J, but this isn't correct either, because if we did this, so I is array.length, and array is the basic thing. So it's this first dimension here. So it's still 4. So I is still this dimension. If we put I here, it would try to go 4 in this dimension, which is incorrect. What we want to switch though is what we can switch though is right here. Instead of doing I is less than array.length, we can kind of do array 0.length. So this specifically only works with rectangular arrays. I know it's a little weird, but that's what we got for this kind of iteration through, because normally you don't do this, because it really is more formally set up. Like this is the formal setup. And like they extend in this direction. So you normally want to iterate through like this, going down here, starting at I equals 0, doing all of those, then 1, doing all of those. But so this only, because what we're doing right now is going down this way, and that goes against how the array is actually set up internally. It's an array of arrays. The second dimension arrays are set up like this. So we're jumping across multiple arrays by doing it like this. So, okay, so yeah, this only works for, well, actually, I bet we could do int j equals 0. And nothing there. And then j. And then plus plus j? Hold up, does that work? Yeah, because 0. No, this doesn't work. This doesn't work. This can't. J, so going through each of the, I'm thinking on the fly, guys. Things get real bad when I start thinking on the fly. So we're gonna stop doing that. If someone has a question about it, we can work there. But this is definitely not the standard way. I've never seen people get asked questions about this way, but I'm just saying, just showing you. You can kind of brute force it with this. Yes. Yeah, there we go. So this outer for loop is array 0.length. So it's assuming that all of the secondary arrays have the same length, which we'll talk about non-standard ones later. But so array 0 is this one. Is this one. So it has a length of 2. So I starts at 0 and we go until 2. But then j starts at 0 and we go till array.length, which is this longer bit here. Because this one is set up more like that. There you go. That helps me. So yeah, array.length is this 4 here. Array 0.length is 2. So with that, we're saying this. So when we increment j in this internal for loop, we go like that. Awesome. So I'm not going to do it for the rest of them because I would like to move on. But there you go. You definitely need to know how to do these. This one's a little less standard. Okay. So I definitely went off the rails from what was talked about here. So yeah, what are 2D arrays? They're arrays of arrays. Like I said, I like to think about it like this. So the base thing is this right here. So this is the first array. It's got 4 elements. Each of those elements are arrays. And then right here, each of those arrays has 2 elements when we set it up like this with 4, 2. Because this makes a rectangular array, so it looks pretty like that. So I talk about it here. Oh, and then here it's showing how each of those internal ones can be a different length. So just recreate this setup. So it's got 4, it's got 2 and then a blank. So 2 and then a blank. And so now ARR1 can equal a new int. I think they did 2. And then ARR, oh, here it's 1 equals a new int 3. We did, oh, this is the part, there we go, 0. And so that looks something like, so here it's a 2-dimensional array. So get rid of that. Here, I'll actually just put it in a new place because I don't know how to get rid of those borders. So it's a 2-dimensional array. So it's got 2 little blocks here. There. So these blocks don't exist yet. How do can I make them bold? Thick. Ooh, there we go. I like that. Okay. So yeah, they exist as like they're reserved to exist, but they don't have anything in here. But when we do AR 0 equals 2 and AR 1 equals 3, that is the point Oh, no, that's not what I want. That's the point. So this is now 2. And it's now 3. Undo. I'll just get out the pen. The pen was good. 2, and this is now 3. And at this specific point, so when they said AR0 equals new int 2 and AR1 equals new int 3, then these get filled with 0. Before that, let's say we added, this was a 3 dimension. So right here. So before that, if they don't exist yet, the value, put it in quotes because it's the opposite of a value, would be null. So if I went in here and it's system.out.println ARR2, and I run this, it's null. Now, if you had tried to print out any of the other arrays, you wouldn't have gotten any values. You would have gotten a random assortment of numbers. And that's because how we talked about last time, where arrays are memory addresses. So this is the garbage memory address. Not garbage, but it's a memory address that you don't have to understand. But specifically with 0, I mean specifically with when it's not initialized yet, it doesn't even have a memory address that you don't understand. It has a value of null. Cool. So yeah, I talked about different. So yeah, now with the different sized arrays, everything we talked about over here still works completely fine. If you use I as this part, as the rows, and J as the columns, you'll be perfectly fine, because the length of this array of the length of, let's say this ARR. So the length of ARR is 3, but then the length of ARR0 is 2, ARR1 is 3, ARR3 I guess would be 0. Yeah, ARR3 would be 0. Actually, I wonder if you could even do ARR2.length. Yeah, okay, actually you can't even do that because it's a length of 0 would be if I did ARR2 equals new int 0. There we go. But with an explicit length of 0, it looks, instead of null, it looks like that. Ooh, too much. There we go. Why can't what am I missing? I literally just, oh, it's because it's the erase tool now. There we go. There we go. So it's more like that, and then delete. So it looks like that now instead of null. But it does exist. It's just a length of 0. What is that? Oh, and this is probably 0. I don't know why there's a 1 there. Okay, cool. So the difference between null and then an empty array versus null, they're different concepts, and you can't do anything to a null. Okay. So yeah, creating an array just like a 1D array. So double square brackets in the initialization, and then double square brackets when you're actually declaring it. But there's a couple ways you can declare it. Just like separate right here with declaration and initialization in different parts. Do it all at once. You don't have to give it a second dimension with a 2D array. And so that just makes all the elements of the array null. So just non-existent completely. You can't put an empty first one and a non-empty second one. Because that'd be like saying, we don't know how many rows there are, but all of your rows are 4. But with arrays, the internal of an array looks like this, with the length of ARR being 3, and then each of those elements being an array. So this is what like internally it kind of looks like. And so you can't have that second dimension exist without a first dimension. So yeah, right here, kind of showing you what's going on in the back end, like we did with an array. So we got array 3, 4. So the A equals new int 3. So A itself is a memory address, and so at the memory address that A is storing, there's 3 elements, and each of those elements is a memory address, and at each of those there's a 4-length array. Cool. On this same point, you can do something like, assuming they talk about it there, but if you do int array equals new int 1, 1, 2, 3. There we go. So this is actually a 2-dimensional array. So right now, this array, the dimensions are 1, 3. So that's the sizes are 1 and 3. But now we can do separated by commas. We can increase comma 2. So now it's 2, then it's 3 for the first one, and I don't know how to write. There's no correct syntax for this. But the first element has a length of 3, and the second element has a length of 0. Personally, I would write a 2-dimensional array like that. I don't like how it's lining up. There we go. Like, I personally prefer to write them kind of like that, so you can see where everything lines up. So this is a 2 by 3 completely. You can change this internal one to be more or less kind of thing. So just like with a 1-dimensional array, how you can manually code it out like that, you can do the same thing with the 2D array. Yeah, I assumed they would show that before here, but that's fine. So visualization, we already kind of covered that. Though they used a square, because they're showing the values. Okay, so this is good. This is nice. This is like I said, I personally view arrays like this, and most people view arrays like this, where it's 3, 3, and row 0, row 1, row 2, column 0, column 1, column 2. And then the first dimension is going down, the second dimension is going across. And I know that might be a little weird if you think about it as like X and Y. You'd put X in the second one and Y in the first one. What? It's like a matrix? Oh, matrix. Yes. So Ernesto said it's like a matrix. Yes. Arrays are definitely used for matrix calculations internally for a lot of programs. So there you go. Now I keep saying that like it can be other ways, and you might be like glossing over, but now that it's like shown it here, like this is the correct way, and I keep saying it, I'm going to show you why. Because in Connect 4, yeah, right here. So Connect 4, we give you this little line of instructions. Elements in the array should be accessible via row, major, indexing, board, row, column. In addition, the data should be stored so that row 0 is at the bottom of the board. So we say this specifically, and we show you this, and we say to test it, or your method test in Zywas will fail. It's actually where if you don't do this, there's one specific test you'll fail, because there's only one test really manually go into your array and change stuff. But yeah, so it's just a singular test, and we're in here specifically. With this setup, you're supposed to do it like this one. No, not this one. Oh yeah, no, this one right here. I don't know why I put a 1 there. It's 0, 1, yes. Yeah, 0, 0 in the bottom left here and go up. So with lab 5, you specifically have to use this setup. And yeah, there's one, unless they've changed it from the last like 2 semesters where people have issues with this. If you don't do it, you only get 1 point off. So if that really is hindering you, you don't have to worry about it. And actually, if you do it the wrong way, it's really easy to switch it. But you, like, if you don't know how to switch it, it can be a pain because it's not just a one thing. It's 2 places you have to change things. Yeah, the reason why it's hard to go from any way to the correct way is that you only get 1 point off for doing it completely wrong. But if you switch one thing in your code, you get like everything wrong. You have to switch 2 things to get it working perfectly. So some people, they get it, so they only have 1 point off. They're like, oh, I need to change this one thing. So they change, and then more points go wrong. And they're like, oh, I'll go back. I don't want to have all these points off. But you have to keep going forward in the process of changing all your code into this format for it to work. But highly recommend just starting from this set. Thinking about your array like this from the start will help you a lot. Okay. Oh yeah, and since I'm talking about this one specifically, let me just add in. There. So you're think about it like that specifically. Okay. Cool. But either way, if you store something at 0, 0, it's going to 0, 0 no matter what. We just change where 0, 0 is. So if you say array 0, 0 equals 3, no matter how you're thinking about it, the 0, 0 element is what changes. So it's really just how you think about it. And we're writing code, obviously, to iterate through it too, but yeah, okay. Initializing array. Oh, they talk about it right here. They took a hot second because they discussed it here, whatever. So here is an array that's not rectangular at all. So you can assign individual elements to things like this. But then here's how you can create a whole array specifying each individual element, and all of the rows now have different dimensions. Like I said, even with this, so I'm gonna copy and paste this and put it in our thing. So even with this array, if we create that for loop, ARR.length for I, J, ARR I dot length. So I realized I never actually ran this code. And then we're gonna put a little system.out.println, just a print line there. And then we're gonna add a space there. And this will probably be useful for your lab too, just because when you're printing out stuff, even though your array is individual dashes or X's and zeros, you need to put spaces in between everything and put them on new lines and stuff. Let's see, with this, if we run it, ooh, this is a print line. Whoops. Don't want a print line there, just a print. There we go. So this prints out individually, and it looks more like this. Oh, now it's lining up perfectly. Cool. Awesome. So yeah, it looks more like that. Okay, accessing elements in a 2D array. So yeah, row, column, index again. This is like entirely how you want to think about it, but we already covered that a lot. Length of a 2D array. So we kind of showed that in here. Array.length in this case is 3 because there's 1, 2, 3 elements. So there's 3 arrays stored in this 2D array. So array.length is how many arrays are stored in an array. And then array at a specific index gives you like the 3, 4, or 1. So if instead of this we did, Like let's say we just printed out array.length and ran that. So you see the first one has a length of 3, 4, 1. Okay. Iterating through an array. So again, double for loops we talked about. So we kind of went over that a fair bit with the different ways you can do it here. But here it is more explicitly. And again, for the lab, you're going to have to start I at 4 and then go to 0. So it would be like flipped. Iterating through an array. Ooh, ease. Oh, wait, no. What's going on here? Oh, so this is just making a length 3 array, and then at each of the individual ones, giving them a different value, giving them a different. Giving them a different length. So each array in this 2D array has a different length, but this still works. It's like here. Because even we made a variable length array in there. So if we do AR I j equals I plus j. Copy and paste this, Control Z, back to there, back to there, there. So if we run this, oh, I don't need to print, whatever. So what this is doing is adding the I and j index and replacing the value in it to there. So that's kind of what this is doing. Oh, here. This will be useful for like setting up your board or putting at a specific index a new value or something. Because for ours, we would make it like a character array. That's valid, right? Yeah. And then dash. For like the lab setup, you would do something like this, except it'd be for a rectangular array, not a variable length array. Ooh, connect 4. Oh, so this, cool. I didn't know this had that. Okay, so in the lab, you'll use a 2D array to play connect 4. You could literally just play connect 4 with it, like with a friend if you wanted to, with your end program. You can display the game board and tokens, keep track of player moves, and determine the winner of a game or state that it's a tie. So for keeping track of the player moves, that's kind of, you're keeping track of the player moves just because every round of the game, so after everyone makes a move, you display the new board. That's what that means. So you'll be displaying a new board every time. And then for checking for win conditions, you only check horizontally and vertically. So very specifically, you only check horizontally and vertically. So you don't have to do any diagonal stuff. And what that means is that if someone inserts a chip, so we're passing around the arrays and the parameters. The print board and initialize board are just like visual stuff, but then the insert chip, you're given an array and then a column and a chip type. And so at that column, you put it in the first empty slot. The first empty slot. I guess it'd be the last empty slot, yeah. But then this returns the row that you inserted at. And so that in here in check winner, you're given an array, column, row, and chip type. The column and the row are where the last chip was just placed. And so you need to only check the column and row that chip is in. That's what that is interesting about. So you really, instead of a nested for loop, you just need 2 separate for loops. One for checking the entire column that the chip was put in, and one for checking the entire row that the chip was put in. Does that make sense to everyone conceptually? So like if I say 2, 3, here, I can go to here. So if I say 1, 2 right here, so this element, fill it with something, sure. You just need to check all of this if there's 4 in a row, and then all of this if there's 4 in a row. But those are just singular for loops, not a nested for loop to check everything. This and this. Okay. That's that. And yeah, the reason why we have we're passing the character array in everywhere. So when you're done with these functions, we could pass in our own array. That's why you have to follow this convention that we tell you here, because there's one test where we make our own array and pass it in, and if it's not following these conventions, you'll fail the test. Cool. Before you start, read the full lab description, obviously. Take a look at the required methods so you understand them. I can't tell you how many times I've had people not read these descriptions and then just try to make it up based off what the name of the function and then the parameter, and it does some weird stuff. So this will print the board. So just printing the board is a nested for loop that goes through each element and prints them. And make sure you go through the elements in the right order. So it's not starting at 0, 0. It's starting at something else. Initialize board, this is set all elements to a dash. So the thing that I did right here, you could actually probably just copy and paste that. So I'm not going to put that up anymore. I guess it's recorded, so you can go back. But yeah, that kind of thing right there. That's the initialization for the board, going through each element and assigning it the dash. And then an insert chip, place a token into the column that the user's chosen. We'll find the next available spot in the column. There's already tokens there. So there we go. Okay. So because 0, 0 is this bottom thing right here, when you're given a column, so let's say, oh gosh, I have hiccups. Let's say column 1 right here. So if you're given column 1, you'll check index 0 of column 1. If that's filled with something, you don't put the chip there. Check column 1 of row 0. And then if there's not something there, then you put it there. So the reason why we have you start at 0, 0 is because theoretically it makes it easier to insert chips, because you just start at 0, check 0. If it's filled, no, don't do anything. Yada, yada, yada. Keep going up until you find one that's not filled. You could do the same thing, though. You could do this project in a different orientation. Just instead of starting at 0, you start at another row or something. But yeah, start at 0. Bottom left is 0, 0 for here. That's a requirement. Okay. So yeah, read all the methods, see what they do. Oh, and then check if winner, you're given an array, a column in a row that the last chip was placed in, and then the chip type of the person who last placed one. And then you just check to see that if at that point in time for that chip type, did they win? That's all you need to do. We got a question. So random question, when reading a long or short, do the values start at 0 like an array, or does it start at 1? When reading. Random question. When you're reading a long or short, do the values start at 0 like an array, or does it start at 1? What arrays don't start? Oh, an integer array specifically? Is that what you're talking about, Evan? So by an array, do you mean integers do in arrays? Because long and short start at 0s like integers do in arrays, but arrays don't start at 0. When reading along. Or do you mean indexing along? Because you don't index along or short, like the boxes themselves. So do you mean like long? Oh God. Equals new array equals new long. And then let's put just a 2 or something. But longs and shorts can't use character at. Yeah, longs and shorts don't have character at. That's not a thing. Okay, string, yes. String, yes. Strings also start at 0. Yeah. If I see you guys, I haven't graded the test yet, but I talked about it before the test. If I see you guys put in like a long var1, so if I see you doing this and then var1 dot character at, that's, yeah. That's not legal. Does everything start at 0 default? I mean, everything's a strong word just because someone could make their own data type that doesn't start at 0. Also, y'all, Evan, you don't have to DM me this. You could ask it in whatever. So I'm being asked if everything starts at 0. I don't want to say everything, especially because I now know a programming language that doesn't start at 0, even for their array indexing. But I'm not going to say everything starts at 0s, but the standard is starting at 0. Yes, the standard is that things start at index 0. And the reason why, it goes back to arrays being memory addresses, and arrays store the address of the first element. And so when you do int equals new int 2, it's like that. If you did, let's say instead of that, 1, 2, 3, 4. Like, let's say we had that. If I do AR plus 1, 0, can you not do that in Java? Java doesn't really have any fun. Java doesn't really have any fun. Okay, fine. C++ you can do that. But yeah, things start at 0. Yeah, I won't go into that then since Java can't do that. Okay. Any other questions on that topic? Cool. Okay. So So yeah, your board will be stored as a 2D array. The space can either be an X, a 0, or a dash. So it'll start as dashes, but as they place stuff in, it'll be X's and 0s. It's X's and O's, sorry. It's not 0s, it's O's. Maybe if I've been saying 0s. Pay attention to the orientation of your board. Like I said, row 0 must be the bottom of your board. And then the board should be printed top down. What it's meaning by that is right here. So since 0, 0 is the bottom of your board, you got to print it starting at row 3 instead of row 0. And then win condition, if there's 4 in a row, horizontal or vertically, not diagonally. You're not checking that. Don't worry about it. So this is kind of just showing you what? Oh, this is checking sure. Yeah, that's fine. Be careful not to check an index that's outside of the bounds of the array. What it's saying by that is that if for some reason inside your for loop you have a +1 or a -1 or something, that means if you get to either end, so like if it's +1 and you get to the end of your array, so you get to j is equal to array.length -1, if you add +1 to j and try to access that element, you've gone too far. Like your array doesn't have an element for that. So that's an illegal index. So just keep, if inside your for loop you have pluses or minuses, you have to make sure inside your arrays like this, you have to make sure that you check your conditions of your for loop. So like array dot length. There's no, I don't have an array int. Fine equals new int 2, 2. There we go. So like with here, if you did something like ARR I plus 1 anywhere in there, 0, sure. Then you'd probably, why is this mad? There we go. So you have this right here. This is going to cause an error. Index out of bounds exception 2. So the 2 is saying I tried to go to index 2, but this is the length of 2, so there's not actually an element of 2. So you'd have to do like -1. Now it works. Okay. So that's 2D arrays, and I think we basically covered everything in the lab now. So yeah, make sure you don't have any errors. The user gives you the height and width. So in this case, it's 4 and 5. You don't have to error check it, so just do like next int for it. And then you pass those variables into these two elements. Yeah, so it'll be a valid, so everything will be valid, but it can do horizontally, vertically. Oh, I got a question. Can I go over writing test methods for the 2D arrays? What kind of test methods? Can you go over writing the test methods? But for all of what? It's like, oh, just like these right here, like how do I write them? Is that what you mean, Danielle? The whole point of the lab is to test you on doing that. I'm not going to go over all of them, no. We can talk about them. So like here, print board, you're going to have to go through the array starting from the top of the array. So you're printing it top down, but since the row 0, 0 is right here, top down starts at 3, 0. So we talked about how to write a for loop like that. So start from 3, 0, do a nested for loop to print all those elements, and that's what it does. It just does it for any passed in array. And with this one's right here, if you start I as this dimension and J as this one, it doesn't matter if they were like weird arrays either, so you don't have to worry about that. So yeah, that's a nested for loop for that. Initialize board is going to look very similar to print board, except instead of printing anything out, you're just going through all the elements and assigning them to a dash. So these two are almost the exact same, just one's printing stuff out and then one's assigning it to a dash. Insert chip, you're given an array. Start at the bottom of the array, which for our thing is 0. So starting at row 0, whatever column they give you, so let's say they did column 1, you start at 0, 1, check to see if that's empty. If it not empty, you go up 1. Oh, what did I do? If that's empty, so like if this, like say our thing was like this. Oh God, what's happening? Stop. What are you doing? Enter, sure, enter. enter, 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 enter. There we go. Okay. So imagine this was our array. So we're given column 1. So column 1, we check to see if this is empty. It's not. Go to this one. It's not. This one, it is empty. So we insert the next chip. And the next chip we insert is just whatever's the passed in chip type. So let's say the passed in chip type is 0 or O, sorry. Just put an O there. And then it returns the row that the token was placed in. So the row here returns 2. Everything else was void, but this one returns the row that you just inserted at, so that gets inserted at 2. And again, right here, we tell you, where's the assumptions? Assumptions, the column that the user placed the token into has a space, so you don't need to do any kind of error checking for that. So now that we've done insert chip, check if winner. So you should be checking if winner every single time. But in here, you're given the row of 2 and the column 1. And then the chip type, we're going to say chip type of 0, but technically we could give you any chip type. Just we're give you a column and a row, and then we give you a chip type. It doesn't have to be, that one doesn't have to be legal because you're not checking that. You're just checking to see now that if there's a 4 in a row in that row or 4 in a row in that column. So both those answers are no. If, let's say, it looked like this, so X and O had been back and forth, and then O put 1 there. So now the check if winner would be 3, 1. We could check to see the row. There's not 4 in a row. But this column, like you don't have to start at the end. So like, let's say there was like another thing there, sure. You don't have to start from this 3, 1, but you can start at the top or the bottom and just go through. So it's like there's 1 0 in a row, another 0 in a row, another 0, another 0. Hey, that's 4 in a row. Just you can break everything there, or actually it just at that point when you find 4 in a row, you can just return true. And so return true, that means that chip type 1. So they're the winner. So yeah, for writing it, that is the whole, the whole point is that you guys should be able to write this. If there's something you don't understand about it, we can go into like that specific part you don't understand, like how do we iterate through this passed in array? Like we can talk about iterating through any array. But the whole point is that you guys got to apply your knowledge to do these. Okay, but did that help at all, Danielle? I hope it did, just like talking through it. And this is recorded, so I'll posting it on YouTube, and we definitely talked about some stuff that can help with like iterating through arrays. Just remember that insert chip, check if winner, insert chip and check if winner should not have nested for loops in them. I'm just going to say that because both of those you're given a dimension or given multiple dimensions. So insert chip should just be a single for loop. Check if winner should be 2 for loops, but not nested. But initialize board and print board will be nested for loops. And these are going to be character arrays, so make sure you're dealing with characters. Yeah. Okay. So with that, how much time do we got left? So we end at 11:30. So yeah, we're within the hour mark. Actually, we're nearing the 40-minute mark, so I got to wrap up. So yeah, lab 4, 2D arrays, lab 5, we're going to talk about the last 40 to 60 minutes. We can set on like project 2C stuff and any questions about that. So yeah, at this point, we're done. The last 40 minutes of lab will be for Q&A. Also, if anyone wants to peer program, here, I'm going to stop recording now. So we're done.